There's a few different ways to graph a parabola that's in standard form. I'm going to show you the way that I like to use. So here's our equation. It is in standard form. The first thing we'll want to do is we always want to take a 4 out of whatever this value right here is. It was part of our standard form equation from the notes. So we always want to take that number basically and divide it by 4, and if you have a nice answer, a nice problem, it'll be something that's a multiple of 4. If not, well, that's life, I guess. So taking -16 and dividing it by 4 gets us a -4 right there. That value is important because that -4 is going to represent the p-value, or the distance to the focus. Okay, so it's going to be important for when we start to graph this. So we've done that first. Let's go ahead and start analyzing this here on the side, and then we can make our picture of this parabola. So the vertex, kind of like the center of the circle, the vertex is made up of your h and k values. Now just be careful because sometimes y is going to be on this side of the equation. So make sure x is always first, whatever side it's on, make sure y is always second. And just like a circle, we want to change the sign of those values. So the vertex of this parabola is going to be at the point 3, -2. Okay, and let's actually go ahead and get that on the graph. So 3, -2 is going to be right there. 3, -2 is going to be right there, representing the vertex of my parabola. Okay, the next thing I would probably do is I want to figure out what direction is this parabola facing. Is it an up, down, left, or right opening parabola? And to do that, using the notes that we took in class, the things I would check for, I would check two things. First, I noticed that this is an x-squared parabola, which means it's either going to open up or down. I also noticed that the p-value is negative. A negative p-value and an x-squared is going to indicate we have a downwards opening parabola. Okay, so that's kind of just what I like to do also to help me graph this. So next up, let's take that p-value and go ahead and get some of these other things filled out down here. So the p-value represents the distance to the focus. Since I know this parabola opens up or down, since I know this parabola opens down, specifically it must look, or in general, it must look something like this. Now that's a really rough sketch, but what that helps me realize is the focus must be somewhere below the vertex. And again, that's why the p-value was negative. So from where your vertex was, let's count down 4 spaces. 1, 2, 3, 4. And there's the focus of our parabola. It's not a point on the parabola, but it's what your parabola sort of wraps around. So it's going to look something like that when we're done. Anyways, let's go ahead and find the coordinates of that. If I count that out, it appears the focus is at the point 3, -6. Okay, next up I can find the directrix. That's the line that's sort of symmetrical with the focus there. And so if the distance to our focus right there is a -4, I want to make sure the distance to my directrix is a +4 above it. So the vertex needs to be right smack in the middle. So let's count up 4 spaces from our vertex. And if it helps, maybe label that vertex so you don't forget what's going on. If I count up 4 spaces, 1, 2, 3, 4, I'm going to draw a horizontal line through there. The directrix is that line that the parabola tries to get away from. It wants to always be farther and farther away from that directrix. Okay, it's a horizontal line, so the equation of a horizontal line will always be y equals, and if I count that up, that is the line y equals 2. Alright, so I'm getting closer and closer to getting my parabola drawn, more and more details for this. Let's see, next up they want the axis of symmetry. Well, that's going to be this time the vertical line that goes right down the middle of my parabola. Vertical lines are always x equals, that appears to be x equals 3. And finally, we have everybody's favorite thing to find, I guess, the lattice rectum, or the endpoints of the lattice rectum. Now, the length of this lattice rectum is always going to be this value. Back in the original problem when we had multiplied by 4. I guess specifically what I should say, it's the absolute value of that, since distance can't be negative. So the length of the lattice rectum is going to be 16. Well, that needs to be evenly split on either side of my parabola. So what I'm going to do is take that value and then divide it by 2. And so what I'll do then, finding a value of 8, what that's going to tell me is from the focus, which was this value down here. And again, you may want to label these as you go so you remember what's what. From that focus, I'm going to count 8 spaces in either direction to get the endpoints of the lattice rectum. So if I count to the left, 1, 2, 3, 4, 5, 6, 7, 8 appears to be about there. Now this will be a point on your parabola, so it's going to go something like that. And I'll count 8 spaces the other way from the focus. 1, 2, 3, 4, 5, 6, 7. Oops, I end up a little bit off my graph. It would be about right there, though, I suppose. That's another point on your parabola. And so, oops, not a great looking graph, but good enough. If you want to draw that in, I suppose that would be a good idea too. That orange dash line right there represents the lattice rectum. So I'll abbreviate that in there, LR. If I add some other things to my graph, some other labels, there was my vertex, there's the focus. The directrix was this line over here, and then the axis of symmetry was that vertical line. So lots of little details to get on there, but there is your parabola. I guess as the last step, let's actually write down the coordinates of the endpoints of the lattice rectum. So if you count those out in your graph, you'll see that you have endpoints at 11, -6, and at 5, -6. Alright, so there's our parabola. There's a lot of analysis about the details of it. There we go.